Welcome friends. In this tutorial I will show you how to calculate roof truss stress and deflection analysis in Ansys software. So let's see, there is one problem statement. So I'll read this problem statement. Solve the roof truss as shown in figure using FEA software and get the end reaction node displacement solution. Also plot displacement vector and stress contour. Take E is equal to 210 GPa means gigapascal and Poisson's ratio is a 0.3 and uniform cross section area of all element as a 80 mm square. Okay, so there is a roof truss. So first I start Ansys, go to preferences, structural, okay, preprocessor, element type, add edit, add. There is only one link I will select, link 3D finite STN 180, okay, close. Why I will select only one? Because there is only one area and one modulus of elasticity. So after that, real constant, add edit, add, okay. What is the area? 80 mm square. Okay, so first thing, let's check here. All dimension are in a meter. Okay, if only area is a mm square, so I'll convert into meter. Okay, so what is actual conversion of 80? So see here. 80 means 8 e raised to minus 5. Okay, because 80 tends to minus 6. So this is okay, close. Then material properties, material model, structural, linear, elastic, isotropic. What is the Young modulus? 210. Okay, so here is a GPM is e raised to 9 because Newton per meter square. Poisson's ratio is a 0.3. Okay, then okay, material, exit. Now go to modeling, create key point in active CS. So now we have to create a first A, B, C and D point. So let's check here. A, B, C, D, E and F. So there is a total 6 point. Okay, so I'll create a first 6 key element. Then we have to join this. So go to first point, apply. Then second point is a here. Second point is a 1.75, apply. Then third point is a 2.75, apply. Then next point, D point, there is a 3 and there is nothing, 0. Then apply. Then E point, there is only 1. Then apply. Next last point is there is a 2, means F point. Then okay. So total 1, 2, 3, 4 and 5, 6. There is a total 6 point. Now we have to join this. Okay, so look this joint. So go to line inactive coordinate. So 1 to 2, 2 to 3, 3 to 4, then 1 to 5, 5 to 6, 6 to 4. Now 2 to 5 and 3 to 6 and 5 to 3. Okay, so there is a joint. Now go to meshing, mesh tool, line set and pick all. See, here is only one division. Okay, then again raise hidden, mesh, pick all, then raise hidden and close. Okay, so meshing is done. Now apply load. So see here, here is a hinge support and here is a roller support D point. So we can apply load. So load, define load, then apply structural displacement on a key point. So only here is a fixed point. Okay, all degree of freedom is a 0. Okay, now see here, there is a roller support. So go to key point, select here. Okay, so only y direction is a 0, then okay. Okay, after that we have to apply a load. So C point and F point, there is a two loads. C point as a horizontal, F point is a downward. So C is a 80 and F is a 50. Okay, so 80 and 50. So pressure on a key point here. Okay, there is a X direction, so load is 80. Okay, see here, so is towards the right side, so 80 E3 kilonewton. Then okay, on a key point, now here, okay, what is the direction? Y direction. What is the downward? 50 E3. Look at here, 50 kilonewton. Okay, so now here is a apply. So see here, there is a two loads is apply. One is a horizontal, one is a vertical. Then go to solution, solve current load step. Okay, okay, solution is done. So process is done. Now we have to find out the general post processing. In that, plot result, deform shape, deform and deform shape. Okay, so see here, there is a deflection. So white dotted line is the original shape and blue line is a deform shape. Okay, so this is the undeformed, this is a deform. Okay, so go to control plot, nodal solution, degree of freedom solution, displacement vector sum. Okay, so mx apply here is the corner point F point. So there is a total maximum value of displacement is a 0.020437. See here, so blue line is a minimum and red line is a maximum displacement. Then element solution in that stress, one means a stress theory. Then okay, okay, so now there is a no stress is shown. So go to plot, control, style, size and shape. E shape is here is off, so go to check on it, means on. Okay, so see here, there is a stress, maximum stress is a 0.111 into 10 raised to 10. Okay, so total value is 1.11 into 10 raised to 9 is a Newton per meter square. Okay, sorry, meter. So this is the stress. See here, now we have to apply, we have to check reaction and displacement. So go to nodal solution, then degree of freedom solution, displacement vector sum. Okay, okay, so see here, this is the tabulated form value of a displacement of each element 1 to 6, means node 1 to 6 with respect to direction ux uy. Okay, now element solution means stress, one means stress 3. Okay, so see here, there is the each element means each element there has a total two nodes joined for two nodes. So there is a total 7 element. Why 7? Because one element is a incline over here, this element. Okay, so total 7 element and 7 element 7 values. Then here is a reaction solution, all items. Then okay, so reaction, see here, at a first point there is a x direction is a minus 80 kilonewton and In the first point, again there is a minus 3.33 kilonewton y direction. At a 4 point, there is a 53.33 kilonewton. So if suppose there is a there is a total 3 reaction at this point. Okay, now again plot result in that this element table. There is a no in element table. So first we go to element table, define table. Okay, then add first value is suppose by sequence number SMIC1. Okay, then apply. Then second by sequence number NMIC1, apply. Then by sequence number LS1 means stress. Okay, there is a stress. Okay, so there is a SMIC means there is a nodal displacement, NMIC there is a reaction, and LS means there is a stress. So close. Then go to again plot result, element table, SMIC. Okay, so see here there is a value shown for each element. Then again NMIC. Okay, so there is again value shows, and last one is a LS1. So there is a stress value. Okay, so now element show I and J. You can choose one by one also, but I will show you directly as a value. So I will choose this menu, list result. Okay, go to list result. Then where is element table data. Then select 1, 2 and 3 all element. Then OK. Okay, so see here there is a SMIC, there is a NMIC, there is a LS1. So see here there is a some value here. Okay, so that's it. Okay, and one more is a plot control. Go to animate, then deform shape. Then here is a number of frame. Okay, take it. Deform and deform. So see here there is a animation of this roof truss. Okay, thank you.